today on Flipping Science we're going to be looking at electron configuration Year 11 style. So with electron configuration, the whole point of it is we can figure out where the electrons are when they're surrounding the nucleus of a particular atom. If we know where the electrons are, we can figure out how the elements are going to react, so how the atoms are going to react and what they're going to do when they react in terms of electron transfer or sharing. So that's what we're going to look at. We're doing it simple style today, Year 11 style, because that will show us where the electrons are, but we're only going to do for the first 20 elements. So first thing we need to look at, where are the electrons? So if we look at a typical nucleus like this, a typical atom like this, we see the electrons are found in shells that surround the nucleus. Number of electrons you have in the surrounding the nucleus should be equal to the atomic number for a neutral atom. When we get to ions, it's a little bit different. So in the nucleus we've got a positive charge, we need to balance that positive charge with the number of electrons around it. There's rules as to how many electrons you can fit in each shell. So in the first shell you can get 2 electrons, the second shell you can get 8, the second shell you get 8, and to bring us up to 20 we only have 2 in the next one. You can get a lot more than 2 in this shell out here, you can get a lot more in 8 in that shell there too. But for the first 20 we don't really need to worry about those. Alright, so we'll start by basically just doing some examples. We'll start by looking at hydrogen because it's the easiest one. So hydrogen, find it on your periodic table, it's up here, number 1. That big 1 means it's got 1 proton in the nucleus, and therefore in a neutral hydrogen atom it's also got 1 electron. So we'll do hydrogen as our example. So in the centre it's got a charge of +1, it's got 1 proton. That means it has to have 1 electron. The way we fill it in is we go from the inside out, and we can't have any more than this number, 2882 electrons in each shell to start with. So if we've got 1 proton in the nucleus here, we need to have 1 electron. So I'm just going to draw a circle. So for its simple electron configuration, we would just say is 1. Alright, that's hydrogen, nice and easy. Next one we'll do is helium. Alright, so helium. Look on our periodic table, find helium, it's over here. It's got an atomic number of 2, so that means it's got +2 in the nucleus. So 2 protons in the nucleus. That means we need to put in 2 electrons. So again, fill from the inside out, 1 here, 1 here. So we've got 2 there. So when we're writing its electron configuration, we just say it is 2. So nice and easy to start with. Let's do lithium. Alright, so find lithium on the periodic table. It's got an atomic number of 3. So I need to fill in 3 electrons. So +3 in the nucleus. Alright, I need to fill in 3 electrons. Start from the centre and work your way out. So 2 in the first shell. We can't fit any more electrons in this shell, so now we need to put another electron in this shell here. So now when we write down this electron configuration, we'd say it's 2.1. So that means 2 in the first shell, 1 in the second shell. Right, we'll skip a few. Let's do carbon, number 6. So do carbon over here. Find it on the periodic table. Atomic number is 6, so it's got +6. So we need to have 6 electrons. So 2 in the first shell, and then we need to have 4 more electrons. So 1, 2, 3, 4. That gives an electron configuration of 2, 4. What these numbers mean is you've got each number of this in each respective shell. So 2 in the first shell, 4 in the next shell. We'll work our way out. We'll do something a bit more complicated. Let's do sodium. Okay. So sodium, number 11 on the periodic table. So we've got charge of +11. So now we need to put in 11 electrons. So we'll start with 2 here. So that means we've got 9 left. So 1, 2, 3, 4, 5, 6, 7, 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 1 electron left over. So we're going to put that in the third shell. So now our electron configuration for sodium is 2 in the first shell, 8 in the second shell, 1 in the outer shell. Okay, that's sodium. We'll do one more example and then we'll look at why this is important. So let's do calcium. Do calcium. Look on the periodic table, its number is 20. So we need to fill in 20 electrons. So 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell, so we're up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 in the next shell. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've got 2 more. Put 1 on that side, 1 on that side. So our electron configuration for calcium, 2 in the first shell, 8 in the next shell, 8 in the next shell, and 2 in the outer shell. Why is this electron configuration important? It tells us how these things are going to react. If we look at calcium, find calcium on the periodic table. So here's calcium over here. We can tell a few things by looking at the electron configuration about how calcium is going to react. It's got these 2 electrons in its outermost shell. That's not very stable. So when it reacts, it's going to lose those 2 electrons from the outermost shell. That'll give it an electron configuration of 2.8.8. What that means is it's got a full outer shell, which is very stable. If it's got a full outer shell that's very stable, the problem with that is it's lost 2 electrons. It's got 2 more protons in the nucleus than it has electrons in the outer shell. So that gives it an overall charge of +2. So that tells us what kind of charge the calcium ion is going to be. It's going to be a +2 charge because it's lost those 2 electrons in the outermost shell. This works for all the ones that we've looked at so far. So if we go back to sodium, so if we look at sodium, alright, it's got an electron configuration of 2.8.1, so 2 in the first shell, 8 in the second shell, 1 in the third shell. If we look at how sodium is going to react, it's got this electron out here that is sitting around. That's unstable because it's just there by itself. It wants to have that 8 in the outermost shell. So it loses that one. It'll get an electron configuration of 2.8, but it'll have 1 more proton in the nucleus than it has electrons, so that gives it a charge of +1. If we look at carbon as an example, if we look at its electron configuration, you can see it's got 2 electrons in the first shell and 4 electrons in the outer shell. What that means is it needs to fill these 4 spaces with electrons to get stable. And one way it can do that is sharing electrons with other elements. And we'll look at how that happens in covalent bonding a bit later on. Another thing we can see from looking at the electron configuration is where these things sit on the periodic table. If I look at my group numbers in the periodic table, they are exactly the same as the number of electrons in the outermost shell. So if I look at carbon here, it's 2.4, so it's got 4 electrons in its outermost shell, so that means its group is group 4. Right? If I look at how many shells it has with electrons in it, it's got 2 shells with electrons in it, that gives us period 2. And this works for any of the other elements we've looked at. So if we look at lithium, we can see its electron configuration, 2.1. So it's got 1 electron in the outermost shell, that means it's in group 1. It's got 2 shells with electrons in it, that gives us period 2. So period 2, group 1, there's lithium. So that's a little bit about electron configuration for the first 20 elements. This has been Flipping Science. See ya.